Cisco Certified Network Associate Day 16. Welcome back everybody, I'm Imran Rafa, your trainer for this entire series. Today we would be dealing with setting up of a small office network. Now we have reached a stage in our training that we have discussed about switches, right? So this would be the last video on Cisco switches. Of course we'll come back to switches a little later. So in the next video we'll look at a roadmap so that everybody understands where we are going and how we are going, right? So this would be the last video on switches for ICND level 1 topics. So we would start with routing from day 18 onwards. Day 17, that's the next video. What I'm going to do is I'm going to just do an overview of what we have covered and where we are going, so we all are on the same page of what to expect from this series, right? So without wasting much time, let's get straight into today's class. But before we start, I would ask you to pause this video, subscribe to my channel. You can click on the bottom link where you see here YouTube/networking Inc. Just click there, it'll automatically subscribe to the channel. And also please like our page on Facebook, and you also know our website, that is nwking.org, and you can visit us there to know more about our future series, right? So without wasting much time, let's get straight into today's class. Today we would be dealing with setting up an office network. So if you break that setting up process or the project into three things, it would be, first thing would be to understand the network requirement. So we need to understand what the office is required. So if you are tasked with setting up a network, office, small office, home office, whatever, first we need to understand what is the requirement, right? Second, we would discuss about the designs, how we are planning to implement and satisfy those requirements. And of course the third thing is the physical configuration, right? So let's assume this is a new office, an office that is set up, and this office has different departments. So there is a marketing department, there is a management office, then there is accounts department, human resource, the server room. Ideally that'll be where somebody from IT, so you would be that person who would be sitting here in the server room, who is basically the IT support, who would look at everything regarding the IT networks of this office. And then we have the sales office, right? And the requirement is such that the management, they said specifically, they've told us that each of these departments should not be able to talk to each other. So that means, you say sales, let's say there are 7 computers in sales office, all these people can only share files or discuss or topic or discuss or communicate with each other. Similarly, marketing can only talk to marketing. Management obviously is on only one computer, so maybe management can stay alone. Maybe if we have more management staff later, we can add that. Accounts will have their own network. Human resource will have their own network, right? So that's our requirement. Now this server room, like I said, is where you would be sitting, right? You are going to be in charge of the entire network. So you have the liberty, because this is just a startup office, you have the liberty to decide how the network is configured, right? How the network is planned, right? So before we go ahead, I need to show you how server rooms are. Now it's up to you as a network administrator to decide if your server room should look like this, or the server room can look like this. Now the difference between this network room and this network room or server room is how disciplined you are. Now if you follow the practices of cable labeling, cable taggings, you can maintain your office in this state. Now there's advantage of having a server room in this condition, where if you can see, every wire is organized. Now all these wires will also have a tag which tells where that cable goes into, right? So this cable could be going into the accounts department, this cable could be going into maybe the management, this cable is going somewhere. So everything is identified, and then all of them are managed well, and they all go through the back pane, and it is well managed. Now if you don't manage, you would say, okay, we only have 10 computers, let's do it this way. Randomly you just pull wires, you plug wires, you put those switches in different format. You don't really have any organized structure of putting those cables. The patch cords are here, right? Initially you might think, okay, it's not a big deal, but then as the computers grow, as your networks grow, as the company grows, you will reach a stage where it's taking too much of your time just to identify these cables. Now you might have a cable cut somewhere, one of those PCs don't stop working. It will be a nightmare for you to identify which is that cable going into which port. So it's always in your interest to have it organized and sorted out like this. Speaking of which, the next critical thing we need to discuss is about wiring, right? So we have spoken a lot about switches, and what we did not speak was about wiring, right? So a Cat5 cable or Cat6 cable, these are called unshielded twisted pair, or they're called UTP cables, right? So these are twisted pairs. Now what is twisted pair? You can see that if you cut a Cat5 or Cat6 cable, you would have 8 pairs like this. So you have green, right? Green solid and green striped, orange solid, orange striped, brown solid and brown striped, blue solid and blue striped, right? So you have 4 pairs, that's 8 cables, and each of those cables are twisted together. Now why do you need twisted? So if you know a little bit of electromagnetic forces, you see that due to electromagnetic interference, electrical signals can't go long distance, right? Now if these cables did not have these twists, those interference from each other's cut out, and the distance that is covered by the electrical signal is reduced. When you twist it, those electromagnetic interference is reduced drastically, such that they can go much larger distance. So we had different cables, category 1, 2, 3, 4, 5, right? So every time the category went up, the distance increased. That is mainly because the twists on those pairs increased. So Cat6 and Cat5, the Cat6 have much more twists than a Cat5 cable. Of course, Cat6 cables are a little more expensive because of these more twists that's there. And of course, they can achieve much higher speeds, and it can go much longer distances, right? So that's basically what it is. So you have Cat5, Cat5e, Cat6. Now these are the 3 types of cables that is still in the market, right? Predominantly, I think Cat5e or Cat5 enhanced is what is being used currently, and a lot of companies are shifting. Now all the new implementations are going with Cat6 cables, right? So if you cut any of those cables, it will have 4 pairs like this. Now you have an RJ45 connector. So this is a connector. This is something we always seen. Now these connectors would be, these wires, these 8 pairs would be inserted into those slots, and you can see there are 8 contacts here, right? Metallic contacts. Now there are 8 pairs, 8 contacts. You insert these inside these grooves and use this tool. This is called the crimping tool. You use this crimping tool, and then it crimps the wire. So the wire gets crimped and it gets stuck. So it stays. That's how you form this cable. So if you have to crimp a cable, you need to know one more information. That information is how do you put those cables, right? This is the wiring diagram, right? This is for Ethernet wiring diagrams. So what you need to do is you take 2 ends of this cable, and you cut that and you remove those 8 pairs of cable on both sides. Now you can put it in this format. So you have this orange striped, then orange, then green striped, then blue striped, then green, then brown stripe and brown. You put that on one side, and the same thing, right? Same thing goes on the other side. So you have the same thing, same combination goes on the other side. Now this is called as a straight through cable, right? Normally when you're connecting two different devices, right? Let's say a switch and a hub, or a switch and a router, you use the straight through cable. If you have to talk to similar devices, so if you want a switch connected to a switch, you have to use another type of cable called the crossover cable. So basically the cable is the same, it's just the configuration. So one end we have the same combination, that's orange stripe orange, green stripe blue, blue stripe green, or a brown stripe brown. The other end we swap. So other end we start with green stripe green, orange stripe, brown, orange, blue, and blue stripe. So basically, if you have to understand this, just think about your phone. In your phone, you talk on the microphone, right? And you listen through the speaker. Now, whatever you speak on the microphone, right? Let's assume you've called your friend and your friend is on the other side. Whatever you speak on the microphone goes to the speaker of the friend's phone, and whatever your friend speaks on his microphone comes to your speakerphone, right? So that is crossover. If whatever you spoke on your microphone went to the microphone of her or his device, and whatever if your speaker and his speakers were connected, it wouldn't work because both of you are similar, right? You know what I mean? Right. So it's not the exact, it's not the most ideal example to give you, but then you understand the thing. So what crossover does is crossover basically crosses whatever transmission wires go into receiver, and receiver wires go into the transmission of the other thing. But on dissimilar device, the devices are configured in such a way that a router and switch have different ports. So if the contact 1 and 2 are for transmission in switches, contact 1 and 2 are receivers in routers, right? I'm just giving an example. So straight through cables work with them, but if it is similar device, then if let's say switch has 1 and 2 as transmission, right? Transmission ports or transmission contacts. Another switch also will have 1 and 2 as transmission contact, right? So this transmission can't go into transmission. It has to go into receiver. So that's why we do a crossover. Now, this is the old thing. Today we have the Auto MDIX. You can Google for Auto MDIX. I'm not going to spend too much time on these because this is something you can always learn from Google. So you can Google for Auto MDIX. Basically what it does is you can use any cable, right? You can use a straight through cable. The devices are intelligent to know what type of cable you're using, and then they will swap their receiver and transmitters, right? So this is how it used to be, but in today's case, Auto MDIX will do the work, right? So just wanted to just go through the cables, right, and how they're connected. So now let's come to the design requirement. All right, so let's open Cisco Pack Tracer, and I'm going to put that same layout which was given to us by this startup office. Now they have they have different departments as we discussed earlier, and we need to lay cable. So what we need to do is first, because they did not want each department to communicate with each other, so the best way is to put independent switches. So we would say I put one switch here, right? I put another switch here. I put another switch for accounts. I put another switch for human resource. I can put another switch for server, and I can put another switch for sales, right? And then let's assume there are different computers. So each of these people have a computer here. Okay, I'm gonna say computer, 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 and computer. Let's assume only 5 are here now. You have a computer here. There's a management computer. There are 2 computers for accounts, and then there's 1 computer for human resource, right? And since all they need is to work without communicating with each other, so just want to communicate only within their department, so we're gonna give it alone, right? So we can do this. This is one way to do this. Now the problem is, right, we can do this for everybody, so I'm gonna just finish that, so everybody is connected. Okay, so this is very safe. Data cannot be touched, right? So let's assume all of these people have their own data, and you don't want, right? You don't want the management to complain that the marketing is doing, better than sales. So you never know. Office politics, right? So you might have somebody in sales who's really good at IT. He might hack into the marketing division's computers and delete their data. So to avoid all that, maybe they had different business requirement, I don't know, but then this is what they said. They don't want any data to interfere with each other, so we're gonna leave. This is one way to do it. Now the problem is, let's assume we have internet. Now this is internet, right? Now this computer, right, I've connected the server room to internet. Now you only have one internet line, right? So you can't give individual internet line for everybody. So basically you have to connect all these switches to the switch. Now that's something you will have to eventually do because of the internet requirement. So you're going to connect all of these devices to your central switch, right? And that switch is in turn connected to the internet, right? All of you with me? Now the problem is again the same thing. If I were to leave all of them in default VLANs, they're all going to be in VLAN 1, so that means to say that this PC can definitely reach this PC because they're all going to be. So to avoid that, we will have to create different VLANs, right? So part of our design, we assume, so let's work with the 192.168.1.0 network, and then /24 obviously, and let's break that into small subnets. So let's create one subnet, VLAN 10 192.168.1.0/26, right? How many hosts will a /26 have? So you can pause the video here and do the math and tell me how many hosts are there in this VLAN. Right, so if you have done your math, you know that /26 is 2-bit borrowing. 2-bit borrowing means it breaks the network into chunks of 64. So you break it into 4 pieces, and you will have 62 valid hosts, right? So we can give 62 voice VLANs. Now the reason we need a separate VLAN for voice is because if we leave voice and data on the same VLAN, like we discussed earlier, it's very easy for us or anybody on the same network for him to run maybe a Wireshark or any wiretapping application, and they can construct the entire phone conversation. So you might have another sales team, let's say from the sales team, you might have one of your sales executive, he's talking on the phone, and somebody else can easily tap onto his phone, entire voice conversation. So ideally you will leave your voice conversation on a separate VLAN to make sure this does not happen. Only phones talk on that VLAN, right? So we give /26, which means 62 valid hosts, so 62 valid phone devices that can be connected to it. Then we create another VLAN in /27. When you say /27, how many? Yes, 31. So you can have 30 valid hosts, so 32 block, 30 valid hosts we can have, and we give that IP address to management, or that VLAN, that is VLAN 20 we give to management, VLAN 30 we give to marketing, VLAN 40 we give to sales, VLAN 50 accounts, VLAN 6 to HR, and VLAN 100 to IT. Okay, so knowing what we know that we have a voice VLAN. So let's assume there are phone devices here. That will be VLAN 10. Management is VLAN 20, so I'm going to say VLAN 20, or rather, yeah, VLAN 20. Then we have marketing, VLAN 30. Then we have sales, VLAN 40, right? Then we have accounts, VLAN 50. Then we have HR, VLAN 60. And then IT is VLAN 100. Okay, are we correct? Let me just quickly check. 10, 20, 30, 40, 50, 60, and VLAN 100. Perfect. Okay, so these are the VLANs that we have part of our design requirements. We have assigned these, right? So remember, I told your server room can be either of those. You can have very unplanned, or you can have in a very organized manner. Now the difference is here, if you do your planning well, if you do your design well, if you take notes, right, make documents, create documentation saying, okay, this is, you can start making documentation, maybe just a notebook, that doesn't matter, just have your documentation there. That accounts is in that network, this is in this network, this is network. So you, as and when your network starts growing, you should be on top of your game. You should know which network is configured which way, what devices are configured, what IP addresses. If you're giving some static IP addresses, what IP addresses are configured where. If you can do all that, you will be on top of your game, and you will have very, very, very little downtime. Now if you're very ad hoc and you keep connecting devices unorganized, you take, you connect any devices anywhere and just creates VLAN, that will really start giving you trouble. So once we have all these things, so VLAN 30, VLAN 20, VLAN 50, VLAN 60, VLAN 100, VLAN 40, we are all in different VLANs. It can only communicate, so this device can communicate within any of these devices in the sales department. Similarly, marketing department computers can talk because they're all the same VLAN. Now the question is this: PC. Now you're okay. This switch has all the VLANs, right? Obviously, because this, if you remember something from our VTP configurations and VLAN configurations, that this switch needs to know all the VLANs, because this is a central switch and all the switches communicate through the switch. So this switch needs to know all the VLANs. But this switch needs to know only VLAN 30 because there's nothing else. Now tomorrow, let's assume there is a case where I might have marketing department, we say it's too big, I might need to partition this and give more sales computers here. Then I will create VLAN 40 also on the switch, right? And I will connect those ports, which is VLAN 40, to those new sales computers. That's okay when we do that. Now if you remember, if you go back to our old videos, we did something called as the management interface. We went to interface VLAN 1, right? And we gave an IP address, right? So now if VLAN 30, if this switch has to be communicated, if these two PCs need to manage this switch, we need to give a interface VLAN 30, which, because these switches work on VLAN 30, they can access interface VLAN 30 and manage the switch. Now think about this. This computer is connected to a port in VLAN 100. Can he, because this computer is where you sit, right? You're the administrator. Now you should be able to manage all these switches remotely. How do we do that? One way, obviously, you can walk to these switches, plug your cable in. You can get out of band access. You can put on a console port and then manage those switches. That's perfectly fine if that's what you want to do. But you would be wanting to remotely manage that switch. But you are on VLAN 100. Now this computer of yours is connected to VLAN 100 port. This switch does not have a VLAN 100. So we need to create a VLAN 100. And if this VLAN 100 PC wants to manage this, here we would have to give an interface VLAN 100, right? You see what I mean to say? So if interface VLAN 30, if you give an IP address interface VLAN 30, that is only these devices who can access, right? But we don't want to create, because we don't want them to manage this device. So we'll never create an interface VLAN 30 there, right? If you don't create an interface VLAN, these people, it is not going to affect them. They can, as a switch, they can communicate with each other. Only if you want to manage it, that's when we give a management IP, which will be interface VLAN 30. But in this case, the management will be done from this PC, the server PC, that's you, right? And you're on VLAN 100. So here we would create interface VLAN 100, and we will allow VLAN 100 here. Similarly, VLAN 100, interface VLAN 100, all these devices will have an interface VLAN 100, and we will give an IP address from this range that this PC is using, right? You with me? So that range would be, if you go back here, IT is 192.168.1.224. So from 224/27 in this network, we will have to give an IP address, right? So we will create interface VLAN 100 and give an IP address from that range. Interface VLAN 100, that IP address range. Interface VLAN 100, that IP address. Interface VLAN IP address. This is how we give. And then this PC sitting here, you can telnet into those devices or SSH into those devices and manage it. You might want to add more devices. You might want to create interface securities, port securities. You might want to do whatever. You can sit in your office and do that. Now that is telnet access or virtual line access, right? If you want to get out of band access, now we spoke about out of band access earlier. If you want to get out of band access to these devices, how will you do that? Now, as an administrator, you would need to have out of band access, right? So to get an out of band access, right, we need another device called the terminal server. Now, another thing, these switches, even though they are in a logical diagram, if you remember, we discussed this earlier, logical and physical. In logical diagram, they are all in different rooms. They could very well be sitting on a tower, right? They could very well be sitting on a tower next to each other. So all of them are sitting next to each other. So it's 0, 1, 2, 3, 4, 5, 6, right? But here we will have to give another device called the terminal server. Now terminal server is where your computer would be connected to, right? And from the terminal server you get octal cables, right? Octal cables are cables that one side has got a serial connector that's connected, and the other side is like a regular Cat5 cable. So all of those cables will go into your console ports. So each of these switch console ports, that octal cable will go. Up to 8 computers can be connected to one octal cable. That's why it's called octal, right? And that terminal server would be connected to your computer, right? So you will connect to the terminal server, and from the terminal server you will get out of band access to each of those devices, right? Now you might say, why do you need, if these devices are anyway in your office, in your server room, then why do you need that? Because your computer at a time can connect only to one console port. So you will have to physically remove the cable and plug it to the next device. If you have a terminal server, you can just press a button on your keyboard and it will switch devices. So you press one button, you will be managing switch 0. You press another button, you're automatically shifted to switch 1. You press another button, you're switched to switch 2. So you can manage, you'll get out of band access to each of those devices by just pressing a button. So normally in a large server environment, you will use a terminal server and manage those devices, right? So that's that. So that's the design part. And the next part is the basic configuration. So each of those devices you can give a host name. I'm not going to go into all these things because we have done this. You can go back and look at the command lines. But what I would suggest is by this time in your series, I would expect you all to practice in such a way that you know these commands by heart. So you know what's the host name command, host name and give a name. You know how to give a logon banner, you need to know how to give a console password and how to enable the password, telnet password, how to enable password, how to do enable password, how to give management IP like we discussed, interface VLAN, whatever, how to give a default gateway, how to do shutdown and shut down a port or open a port, negating command, and saving configuration, right? These are the basic commands. So this is what you will do. So if you follow these 3 steps, understand the requirement, design it on paper, and then get to the configuration, you can very, very easily have a well managed server room, right? So I think this is all for today. Like I said, we would be stopping switching. I think we have enough knowledge for switching to start with routing. So maybe the next video or the video after that, we will start with routing. And things are going to get very, very interesting from now onwards, because routing is a very interesting topic. So we will hit on all the major routing protocols that is required for your CCNA. We will see how to configure that. We will discuss how routing works, and all those things are going to come from the next few videos. So from I think day 18 onwards, we would have routing. Day 17, that's the next video. I'm going to take a break. I'm going to give you a snapshot. So we will look at the curriculum for CCNA. We will see how much we have covered, what we have covered, and we will see what more we have to cover, right? So we all of us have an understanding of where we stand in this, right? So thank you so much. If you have any questions, please feel free to write into me. You can comment on these videos right below. You can please like our Facebook page, because that's where a lot of interactions happen. And of course, you can always email us. Don't forget to visit our website. Our website will give you a timeline of new videos. If at all there are new videos, we will put there whatever new series that we're going to start. That also will have, you will have information there. And very soon I'm going to have a practice session. I'm going to give a provision where you can register online. So you can register at our website. And once you register, this is something that's still under process, but I'm going to give you a sneak peek very soon. Once you register, you can have practice tests. So we will have a simulation test, multiple choice questions. You can practice, and you will see how much you stand. So you could select what is the topic level you want to practice. So you can say switching topic. They're going to give you switching topics, right? And then it's going to be that way. So let's hope that comes out very soon. And thank you so much for watching. See you very, very soon. Bye bye.